Okay. So now that we understand the importance of the normal probability distribution and the standard normal probability distribution, because what they do is they allow us to universally understand how far away any observation is from its average, right? So again, if a stock price is this far away from its average, oh, okay, is that normal or not normal? Is it this far below its average, normal or not normal, right? The standard normal probability distribution lets us know exactly what the relationship is between any observation and its mean, because it is the number of standard deviations that something is away from what's average, right? I mentioned that I normally drive 70 miles an hour. Okay, well, if I normally am between 60 and 80 miles an hour, then if you get a Z score of me that's 4, right? If I'm driving 110, then you would know, whoa, that's way out of line of what's normal for him. But if you have somebody that usually drives between 50 and 100 miles an hour, then you'd say, oh, well, their standard deviation probably isn't, that different, right? They're probably well within what's considered normal. Okay. So the whole point of Z scores is it tells you how common or uncommon a particular observation is in relationship to the rest of the distribution. That's the whole point. It tells you compared to the rest of the data, the rest of the distribution, how weird or not weird, how common or uncommon, how typical or atypical is a particular observation. Okay. Now, we can use that information to calculate the probability of effectively anything. We can calculate the relative likelihood of different events happening. How? Let's go to the whiteboard. Okay. There's going to be 4 cases. So we'll write the 4 probability cases of the standard normal probability distribution. Okay, we'll have case 1, case 2, case 3, and case 4. Okay, so for case 1, we have to find the probability, the P of X, the probability of X occurring. Find the probability of X occurring between an observation and the mean. Okay, so for case 1, we have to find the probability of something occurring between an observation and the mean. So in other words, we want to find this. We want to find the probability. We have to find the probability or the area, find the probability of something occurring that happens between an observation. The observation I wrote as x1, between the observation and the mean. Okay. Case 2, we have to find the probability in, or let's put, find the probability between one of the tails and an observation. Okay, so we have to find the probability between one of the tails and an observation. So in other words, if this is our average and this is our observation, x1, we need to find the probability between one of the tails. This is one of the tails out here, right? This is a tail and an observation. So we would have to find this area, okay? If we found this area, the shaded region out in the tail, we're finding the probability between one of the tails and an observation. So we'd be finding this. That'll give us the area we need, okay? If we find that area, that'll give us the probability we need, okay? Case three, okay. In case three, we're going to find the probability between two observations on different okay. We're going to find the probability between two observations on different sides of the mean. So in other words, we have our mean here. And if we want to find the probability between two observations on different sides of the mean, then what we're trying to do is find this area. We want to find, between x1 and x2, then we're trying to find between this area and that area, okay? So we're trying to go from x1 to x2. We have to find this whole shaded region, okay? And then finally, case four is when we want to find the probability, find the p of x between two observations on the same side. Same side of the mean. So in other words, we want to find we have this mean x2. So in other words, we have to find the area between two observations, x1, x2. They're both on the same side of the mean. And we want to find that area. Okay. So these are the different cases we can have when it comes to the four probability cases of the standard normal probability distribution. If we want to, we can calculate the probability of anything based upon these four cases. Case one, between the mean and an observation. Case two, greater than that observation, right? Rather than trying to find this region, right? Rather than trying to find this, we're finding this. Case three, we have two observations. They're on different sides of the mean, and we want to find in between. Case four, we're finding the probability between two observations that are on the same side of the mean. Okay. As we'll see, this is actually fairly simple. So let's start off with case one. Let's suppose we want to find the probability of IBM stock being between let's see, $112. Let me say it a different way. Between 100 between 100 and $112. If the mean is 100 and the standard deviation is $5. Okay. So in other words, I want to find the probability that IBM stock will finish the day between 100 and $112 if the average of it is 100 and the standard deviation is 5. Okay. So as we'll see, this is kind of simple, right? What we do, we start off by, drawing out the normal probability distribution. I'm going to put 100 in the middle because whatever is the mean goes in the middle. So mu equals 100, mean in the middle. And then what do I want to find out? I want to know if IBM is going to finish the day between 100 and $112. So I'm going to put 112 right here, between 100 $112. Okay. So I want to know this probability. I want to know if it's going to finish the day between 100 and $112. Okay. Well, how do I do that? The way is that I convert to z-scores. I always convert to z-scores. The first thing you do is you convert anything always into a z-score. How do you convert to a z-score? You do a z-score is equal to x minus mu over sigma. Okay. So 100 becomes 0. Why? Well, 100 minus 100 is 0. 0 divided by anything is 0, so this would become 0. Okay. But for 112, let's do x 112 minus mu. Minus mu, what's mu? 100 over 5, sigma 5. 112 minus 100 divided by 5, that's 12 over 5, which gives us 2.4. So what I'm doing here with my brackets and I'm going to change the 2.4 to a bracket. What I'm doing here, this is my original values, right? My original value was 100 and 112, but with the brackets, these are now z-scores, okay? A z-score of 0 means that you are right dead smack on average. You are neither common nor uncommon. You are exactly what is normal. You are as common gets. You are literally the average with a z-score of 0. Okay? But then, if you have a z-score of 2.4, what that indicates, what that is telling you, now that we've converted from the normal probability distribution to the standard normal probability distribution, what that's telling you is that you are exactly 2.4 standard deviations above what is considered normal. Okay, it's 2.4 standard deviations above what is normal. So therefore, that is your z-score. Okay, you're pretty far in excess of what's normal. Not Shaquille O'Neal tall, but maybe that would be like somebody who's 6'6" or 6'7". Okay, right? They're pretty tall, but not exorbitantly tall. Okay, so 2.4. Okay, now that we've got our z-scores, we've converted from to 0 and to 2.4. We have the z-scores. What's next? Okay, this would sort of be like a step one. And then the next thing would be if z equals, let me back that up. If z equals 2.4, okay, now we need to find the area. We need to find the area associated with the z-score. Okay, we need to find the area associated with the z-score. So we need to find the area associated with z equals 2.4. How do we do that? Well, that is where we get the z, t, and f distribution from. That's where that kicks in. We need the z, t, and f distribution, which is provided to you on course content. Okay, it's right there on Blackboard or whatever learning medium we may use. Okay, it's been provided. So once you have an area, once you have a z-score of 2.4, we need to find the area associated with it. How do we do that? Okay, I'm going to switch the screen share with you. Remember, the z-score is 2.4. Okay, 2.4. Give me one second. Okay. So if we have a z-score of 2.4, what we can now do, right? Okay. 2.4, we can look that up in our z distribution, our z table. Okay. This is the first page of the z, t, and f distribution. Okay. Where it says area under the normal curve. This is the z distribution. What we are going to do is we're going to learn how to read this table. Okay. A z score can be broken down into so we have 2.4, right? 2.4 can be broken down into 2.4 and 0.00. Okay, you might notice that in this chart, in this distribution, going down the rows, we have the tenths column 0.0, 0.1, 0.2, 0.3, 0.4, 0.5, right? It goes all the way down to 3. And then across we have the hundredths column 0.01, 0.0, 0.01, 0.02, 0.03, 0.04, 0.05. Okay. So what you're supposed to do is separate your z-scores into tenths and into hundredths. And they give you an example of how to use this at the top. Okay, example, if z equals 1.96, then the probability of 0 to 1.96 is 0.4750. How did they get that? Okay. 1.96 can be broken down into 1.9 and 0.06. Let's take a look. 1.9, let's go down the rows. 1.9, 1.2, 1.3, 1.4, 5, 1.6, 1.7, 1.8, 1.9. Okay, 1.9 and 0.06. 0.06 is over here, right? 0.01, 0.02, 0.03, 0.04, 0.05, 0.06. Okay. If we match up 1.9 and 0.06, 1.9 and 0.06, you get 0.4750. 0.4750. That is exactly what is right here. That's the answer. Okay. So they show you how to do this. If you have a z-score of 1.96, then you end up with a probability or an area under the curve of 1.96. Okay, 1.96. Okay, 0.4750. Okay. So for us, we have a z-score of 2.4. 2.4 can be broken down into 2.4 and 0.00, right? I started us off with an easy one. So 2.40, we go down here, right? 0.1, 0.2, 0.4, 0.5, 1, 1.1, 1.5, 1.6, 1.7, 1.8, 1.9, 2, 2.1, 2.2, 2.3, 2.4. So we have a z-score of 2.4 and 0.00. Okay, 2.4 and 0.00. That area under the curve, that area of 2.40 is 0.4918. That is the area under the curve. That's the answer. 0.4918 is the area under the curve. And since area is probability, that means that the probability, the answer to the question is 0.4918. Okay, 0.4918. That's our answer. Okay. Just to make sure we're clear here, right? If my z-score was 0.93, if it was if I had a z-score of 0.93, then I could do 0.9 and 0.03. So 0.9, 0.03, that would be 0.3238. Okay, 3238 would be the area under the curve. If I wanted to know the area under the curve with a z-score of 1.29, then I could do z-score 1.2, right? I'd go down here 1.2, and then across 0.09, right? 0.09, 1.2, and 0.09. That area under the curve would be 0.4015. Okay, that area, that's the area under the curve, which means that it is also the probability. Okay. Finally, if I had area under the curve, if I had a z-score of 3.04, right? If I had 3.04, then 3.04 would break out to, I can scroll just 3.04 would give me 3.04, right? 3.04. That would give me an area under the curve of 0.4988. That would be the area under the curve, which is also the probability. Okay. So again, I had a z-score of 2.40. 2.40 gets me 2.40. 2.40 is 0.4918. 0.4918. If I'm doing 0.4918. So then my area, if z is equal to 2.4, then now we need to find the area associated with the z-score, the area of the z-score. The area of z equals 2.4 is 0.4918, which means that there is a 49.18% chance. There's a 49.18% chance. 0.4918. There's a 49.18% chance of IBM stock finishing the day between $100 and $112 if the average is 100 and the standard deviation is 5. Okay. And that's correct. That's the probability. Okay. If the average is 100 with a standard deviation of 5, then the probability of the stock finishing the day between 100 and 112 is 49.18%. Okay. So that's case one. Let's try case two. Okay. For case two, we have to find the area. Oops. In the tail. So in other words, let's say, okay, case two, suppose IBM stock has an average of mu equals 100 and a standard deviation of 5, right? Let's say, what's the probability? What's the P of X that IBM stock finishes between, oh, I don't know, $108.50 or more. Okay. So in other words, we want to know, right? So IBM stock is on average, it's $100. Okay. On average, IBM stock is $100. And what we want to know now is what is the probability of IBM stock finishing the day between 108.50 or more. Okay. So going up and over what is considered normal for it. What's normal for it is 100 with a standard deviation of 5. We want to know the probability of IBM stock being 108.50 or more. The way we do that, as always, start with the z-scores. Okay. We're going to start with the z-scores. What do? We do z equals. This is not a very efficient use of space right here. I'm going to go down. Start with the z-scores. So z equals x minus mu over sigma. X, 108.50 minus mu. Mu is 100 divided by sigma. Sigma is 5. That gives me 8.50 over 5. So my z equals 8.5 over 5. Is 1.7. Oops. 1.70. Okay. So as before, right, 0 goes in the middle. And then this x is 1.70. So that means that a stock price of $108.50 is exactly 1.7 standard deviations above what's considered normal. Okay? Above what's considered normal. So now, how would I find this area? How would I find this area? Well, wait a second. I know that this is the standard normal probability distribution. This whole graph, this whole bell curve is the standard normal probability distribution. And I just so happen to know two things about this standard normal probability distribution. The first thing I know is that the total area under the curve, so this, and this, if you add it all up, if you add up the whole area under the curve, it's 1. And I also know that this is symmetrical about the mean. I know that this side, the left side, so this side and this side are equal. Okay. Well, if this side and this side is 1, if together the left half and the right half make 1, then that means that the right half is 0.5. So this total area, right, from the mean over the white and the black regions right here, from the mean over, from the mean to the tail, the white and the black region is 0.5. You put those together, it's 0.5. Well, I want to know what this area is. I just found out that I can figure out what this area is. Okay, I just found out how to get the probability between 100 and 108.50. Okay, in other words, I can find the area associated with 1.7. Okay, if I can find the area associated with 1.7, then I could probably do 0.5, right? So in other words, if the white plus the black is 0.5, why don't I just do 0.5 minus this white area, which will leave me with just the shaded region right here. Simple as that. So if z is 1.70, the area of the z-score equals 1.70, right? Maybe that's a little bit too awkward of a phrasing for some people. Let's see. So if the z-score equals 1.70, then the area of z equals 1.70 is, what's that area? I can go find it. It's right here. 1.70. 1.70 would give me 1.7, right? I just go down my rows, 1.5, 1.6, 1.7, 1.7, 0. 1.70 is 0.4554. 0.4554. That means that this area is 0.4554. Okay, this right here. Well, if I have this area, if this white region is 0.4554, and this whole thing right here, if this whole thing is 0.5, I could just do 0.5 minus 0.4554. That would give me the probability. So the probability, zero point 0.5 minus 0.4554 is 0.0446. Okay, that's my probability right there. So the probability is 0.0446, which means that there is a 4.46% chance that the stock of IBM will finish the day between $108.50 or more. Okay, that's what that's telling me. It's telling me that, again, if the average is 100 with a standard deviation of $5, if I wanted to know, all right, well, what's the chance it's going to be, 108.50 or more? Well, the answer is 4.46% or 0.0446. Okay. That's the probability right there. 4.46%. Okay. So that's case two. Case three. Let's say we want to know, suppose again that the average is 100 with a standard deviation equal to 5. Let's say we want to know what is the probability of IBM stock finishing the day between $92.50 and $103.75. Okay. In other words, I want to know, right? If we do this is case three, right? Average hundreds in the middle. I want to know between 92.50 and 103.70. Okay. 103.75. Okay. So now I want to find the probability of something happening with two observations that are on different sides of the mean. Okay. So in other words, I have observation 1 here. I have observation 2 here. Okay, that's x1. We'll just make this x2. Okay. I want to know this area. How can I do this? I really just have two case ones and then I add them together. Okay. What I'm going to do, I'm going to find this area. I'm going to find this area right here. And then I'm going to find this area. When I find the two areas, I am then going to add the areas. Note, you cannot add z-scores together. Do not add z-scores together. You can only add probability or area together. It wouldn't make sense to add z-scores together. A z-score is just how far an observation is away from the mean, right? It's the number of standard deviations an observation is away from the mean. You would never add my z-score to Shaquille O'Neal's z-score of height. That would make no sense. Okay. Instead, you could add the area of us away from the mean together. I have a probability that I am taller than average. Shaquille O'Neal has a probability that he's taller than average. But you would never add his height to my height and then say, oh, wow, look, that's a 13-foot person. You wouldn't do that. You add probabilities and areas. You do not add z-scores. Okay. So having said that, we can add areas. We can't add z-scores. First thing we're going to do, we're going to convert x1 into a z-score. We're going to convert x2 into a z-score. Once we get those z-scores, then we are going, which I'll write down here. So z1 equals, and z2 equals, right? We already know that 100 is going to become 0 because 0 always gets converted, or the mean always gets converted to 0. But now we're going to convert our x's, the value of our observations. We're going to convert those to z-scores. And then once we get those z-scores, we're going to get the areas. Once we get the z-scores, we get the areas. And once we have the areas, we can add the areas together. Okay. So first things first, z1 equals 92.5 minus, and I'll put remember, this is the formula. So z equals x minus mu over sigma. 9250 minus 100 divided by 5 equals 9250. That's 7.5, negative 7.5 divided by 5, which equals negative 1.5. And then Z2 is going to be 103.75 minus 100 equals divided by 5, 0.75. So this is negative 1.50, and this is 0.75. Okay. Now we need to get the areas associated with them. So the area of this, and then we need to get the second area. Okay. The area associated with negative 1.5 is going to be, we're going to look that up. And then we have to get the area associated with 0.75. We're going to have to look that up too. The area of negative 1.5. The area of 1.5, again, 1.50, right? 1.50, 1.50 gets us 0.4332. 1.50, let's match it up. 1.5, 0.00, 0.4332. Okay, 0.4332. So I'm going to go and write that down in my whiteboard. Okay, 0.4332. And then area 2, I'm going to write this, I'm going to move this a little further to the left here. Okay, area 2. I'm going to find the area of 0.75. 0.75 is 0.7, so 0.2, 0.3, 0.4, 0.4, 0.6, 0.7, so 0.75. Now I need to go is 0.01, 0.02, 0.03, 0.04, 0.05. I need to match up 0.7 and 0.5. 0.7 and 0.05. 0.7 and 0.05 gives me 0.2734. 0.2734. 0.2734. Okay. Now, if I combine these two, okay, if I do 0.4332 plus 0.2734. Okay, in other words, this is 0.4332. That is this area right here. This shaded region has an area of 0.4332. This area, this region between 100 and 103.75, this has an area of 0.2734. Okay. So if I take this area, again, cannot add z-scores. You can only add areas. You can add and subtract areas. You cannot add and subtract z-scores. You can't add my height to Shaquille O'Neal's. But you can say Devin is 10% taller than normal and Shaq is 40% taller than normal. Combined, how much taller than normal are they? That you can say, right? So if you take this area where we add and we're going to add the probabilities together. So we take this area plus this area means that, and we just calculate it here, we have 0.4332 plus 0.2734 gives us 0.7066, or there is a 70.66% chance. There's a 70.66% chance that IBM stock will finish the day between 92.50 and 103.75 if the average is 100 with a standard deviation of 5. Okay. If the average is 100 with a standard deviation of 5, then there's a 70.66% chance that IBM will finish the day between 92.50 and 103.75. Okay, that's case 3. In case 3, we are adding the probability of two things, two intervals, two observations, and they're on different sides of the mean, right? This observation's on this side of the mean. This observation is on this side of the mean. Okay, that's case 3. Now we're going to move on to case 4. Okay, so finally, the last case for case 4. Now we want to know, right? Suppose IBM has an average of 100 and a standard deviation of 5. Okay. Now let's suppose we want to know the probability that IBM stock finishes the day between, I don't know, $89 and $93. Okay, so what is the probability of the stock between $89 and $93? Okay. Now, same as always, our average goes in the middle, right? And we are always going to start by converting to z-scores. Now, what we do here, we're going to convert this to a z-score, this to a z-score. We're going to get the area from 89 to 100. We're going to get this area from 89 to 100. Then we're going to get the area from 93 to 100. Then we're going to do big area minus the little area. Okay. So in other words, What we're going to do, we're going to find the area from 89 to 100. Okay. We're going to find this, we're going to find the black and the white area. Okay. From 89 to 100, there's the black here, there's white here. We're going to find this area from 89 to 100. We're going to find the black and the white. Then we are going to find from 93 to 100. Okay, we're going to find this area, which will be just the white. If then once we have those two areas where we have black and white, and we have just white, if we do black and white minus white, then you will end up with just this region right here. Okay, you'll end up with just the area. You'll end up with just the area between 89 and 93, which is exactly what we're looking for. Okay. So first things first, always convert to z-scores, right? I'll put z-score up here. Okay, z-score is equal to x minus mu over sigma, right? So z1 is going to be equal to 89 minus 100 over 5, which is equal to negative 11 over 5. That's negative 2.1. Okay, so this gets a z-score of negative 2.1. And then z2 is going to be 93 minus 100 over 5, which will be negative 7 over 5, right? Negative 7 over 5 is negative 1.4. Okay. What we're going to do is the area of negative 2.1 minus the area of negative 1.4, which will equal the answer. Okay. So we need to find the area associated with negative 2.1 and the area associated with negative 1.4. Okay, so let's go do that. Okay. The area of negative 2.1, okay, so negative 2.1 is 2.10. So 2.10 gets us to 2.10. That's 0.4821. Okay, 0.4821. So let's go write that down. Okay, this is, whoops. Okay. This is 0.4821 minus the area of 1.4. We have to go find that now. 1.4. Okay, so 1.4, go down 1.40. 1.40 is 0.4192. 1.40 is 0.4192. .4192, and that gives us, I'm just going to do this right now, 0.4821 minus 0.4192, which gives the answer as 0.0629, or there is a 6.29% chance of IBM stock finishing the day between $89 and $93. Okay. So what we did, again, we found the area associated with 2.1. Okay. The area of 2.1, that's this whole area. Okay. That whole area is 0.4821. Okay, so both of those is there. Just this white region right here, just that's 0.4192. Just this from 93 to 100, that area is 0.4192. What we do is we take the big area, as I mentioned, we take the big area minus the smaller area, and that will give us what we're looking for, our little interval here. Our little interval, which popped out as 0.0629 or 6.29%. Okay. And so there's roughly a 6.3% chance that IBM stock will finish the day between $89 and $93 if the average is 100 with a standard deviation of 5. Okay. So let's summarize now what we did, because this is going to conclude our normal probability distribution lesson. What we did is that we said, okay, what's a probability distribution, right? It's the combination of all the potential values that a variable can take on and the relative likelihood of that value occurring, right? It's everything that can happen and the probability of it happening. So, since that's all a probability distribution is, there's literally an infinite number of them that potentially exist out in the universe. There's millions of them being created, there's millions of them being destroyed every single second of every single day. There's an infinite number of them out there. So if I ever asked you, right, what is the probability of blank occurring? There's a lot of probability distributions out there. In order to come up with an answer of the probability of whatever I ask you about occurring, the way we do that is we always convert any probability distribution into the normal probability distribution, specifically the standard normal probability distribution. The standard normal probability distribution is bell-shaped, symmetrical about the mean, it's asymptotic, and area is probability. Okay. It also has a mean of 0 and a standard deviation of 1. Well, that tells us if we can get z-scores, right? The z-scores come out of the standard normal probability distribution. Z-scores tell us how unique, how common or uncommon certain observations are. Well, based upon how common or uncommon certain observations are, that allows us to calculate the percentages, calculate the probabilities of intervals. And when we calculate the probabilities of specific intervals, we can calculate the probability of, say, let's start from the beginning here. We can calculate the probability of our 4 cases occurring. We can calculate, we can calculate the area or the probability between a mean and a specific observation. Or we can calculate the probability between an observation and the tail. Or we can calculate the probability between an observation. Let me scroll down. We can calculate the probability between an observation that's on one side of the mean and an observation that's on a different side of the mean. Or finally, we can calculate the probability, the area between an observation that's on one side of the mean and a second observation that's on the same side of the mean, an interval there. Okay. So now that we have those four cases involving z-scores and the standard normal probability distribution, we can really start to get a sense of quantitative analysis and how to use it, because we're beginning to understand how to calculate the probabilities of virtually anything that exists in the universe. And therefore, we can really start to calculate whether or not our sample statistics are representative of our population parameters. We can start to calculate that specific probability. And that means we can figure out if we have good estimators or not so good estimators, right? Once we have that, we can start moving on to confidence intervals and hypothesis testing and linear regression. So those will be the lessons that come up next.